Good morning, everyone. So our topic for today in chapter 4 is discrete probability distributions. So in section 4.1, the topic is all about probability distributions. So in probability distribution, the random variable is represented by a numerical value associated with each outcome of a probability distribution. It can be denoted by x, and there are two types of random variables: the discrete random variable and the continuous random variable. In discrete random variable, it has a finite or countable number of possible outcomes that can be listed. So for the example drawn 0, 1, 2, 3, and 4, there are dots in here to count the possible outcomes till it is said that this line is infinite. Then the outcome of this is just 1, 2, 3, and 4, 5. Then this has 5 possible outcomes. So in continuous random variables, it has an uncountable number of possible outcomes represented by an interval on the number line. So given the number line 0, 1, 2, 3, and so on until 24, but this line is still infinite, then the possible outcomes can't be counted, since the continuous random variable is said to be the outcomes has uncountable outcomes. So from 0 to 24, we don't even know how many outcomes are in between 0 and 24. So the next is discrete probability distributions. In this must be the following conditions that we must apply to consider what discrete probability distribution is. So number 1 is the probability of each value of the discrete random variable is between 0 and 1 inclusive. So in symbols, this can be written as what I've read. This can be written as like this. And number 2, the second condition is the sum of all probabilities is always equal to 1. So it can be written like this. These two must be the following conditions that must satisfy what discrete probability distribution is. So we'll move to getting the mean. So in constructing these discrete probability distributions, we must have this graph, the score of x and the frequency f. In number 1 has 24 outcomes, 2 has 33 outcomes, 3 has 42 outcomes, 4 has 30 outcomes, and 5 has 21 outcomes, a total of 150 outcomes. In this example, I will read the statement here. An industrial psychologist administered by personality inventory test for a passive-aggressive traits to 150 employees. Each individual was given a whole number score from 1 to 5, which is this, where 1 is extremely passive and 5 is extremely aggressive. A score of 3 indicated neither trait. The results are shown. Construct a probability distribution for the random variable x. And this was the one I've constructed for 150 employees, and from 1 to 5, where 1 is extremely passive and 5 is extremely aggressive. So in this, we're gonna have the solution for 24 divided by 150, which is the total number of employment here, is equal to 0.16. So P2, where 2 has 33, where 33 over 150 employees is equal to 0.22, then P3 is where 42 employees over 150 employees is equal to 0.28. Then 4 times 30 over 150 is equal to 0.20. Then the last one is 5 times the employee, 21 over 150 is equal to 0.14. In this one, we're gonna have a discrete probability distribution where these conditions must satisfy what the given example has. So, in this discrete probability distribution, the first condition is each probability is between 0 and 1 inclusive, and this satisfies all the P1 to P5 where it is greater than 0 and but lesser than 1. So 0.16, 0.22, 0.28, 0.20, and 0.14 is less than 0, is greater than 0 but less than 1. So in the second condition, the sum of all probabilities is equal to 1. So if you have a scientific calculator, try to compute all of this, add this if it equals to 1. So 0.16, 0.22, 0.28, 0.20, 0.14 is absolutely equal to 1, and this satisfies the second condition of the discrete probability distribution. So we're gonna construct a histogram to graph what it is given. So in this histogram, 0.16 is where it belongs here above 0.15. Then the second P2 is 0.22 where it is still above 0.20, where my interval here is 0.5. Each interval here is from 0.5 to 0.30. Each interval is 0.5. So it belongs here 0.22 and so on till P5, which is 0.14. So we're gonna move to what is mean, variance, and standard deviation. Then the last one is expected value. The mean is each value is multiplied by each corresponding probability and the products are needed. It can be written as mu is equal to the summation of x px. So in this one, this symbol is still can be read as like this. Each value is multiplied by its corresponding probability and the products are added. So we'll move to variance and standard deviation. In variance, this can be written as the variance squared is equal to the summation of x minus mean squared px, while the standard deviation is equal to the square root of standard deviation squared. This can be cancelled since the square root and the squared must be cancelled, so it will still be the variance like this is equal to square root of the summation of x minus mean squared px, and then the expected value is equal to the mean of the random variable, which can be written as e of x is equal to the mean, where like this is the mean where each value is multiplied by its corresponding probability and the products are added. Then this expected value is still equal to the mean given, and it can be written as mean is equal to the summation of x px. So that would be all.